Welcome back to the next in our CG shaders tutorial. In this one we are finally going to get to lighting. So to start off, we're going to have a real simple shader that we've already seen before, and I'll just show you what we have here. We have main text and color, and all we're doing here is grabbing the vertex position, grabbing the UV, sticking the color in here, and then we're in our fragment shader, we're just grabbing the pixel out of the image and multiplying it by the color. So it's nothing we haven't seen before. And if we look back over here, we can see there's nothing special going on. So our scene has one extra thing in here. We do have a directional light, and you can see if I disable this, it has no effect. And that is, of course, because we have not implemented any lighting in our shader yet. So for the lighting tutorials, we're only going to be covering the forward rendering path. We're not going to go look into deferred for a couple of reasons. One, it keeps things simple, and two, forward is available on all devices right now, whereas deferred is not available on mobile yet. So the goal of this tutorial is going to be to make a vertex lit shader that'll work with a single directional light. And in the process of doing that, we're also going to learn about includes, which are going to be first thing we do here. So basically, includes allow you to take your common shader code and put them in a separate file. And we've seen this before when we include this Unity CG. This is just a file with a bunch of shader code written in it. And you can see right under it, we have a Prime 31 CG Ink. And when we're dealing with a CG Ink file that is in our actual project, it's important to note that you have to use the relative path to the file. So in this particular case, you can see we're going back a directory, then we're going into the shared directory, and then getting the file. So if we jump back into Unity, we can see our shader is here, and our include file is here. So that's why we have to do that. Okay, so again, includes the big important piece of includes is you can share your shader code, and it helps you to, especially if you have multiple projects, keep one include file that has a whole bunch of stuff that you would normally have duplicated, and you don't have to worry about typos and other errors by doing that. Okay, so first thing we need to do here is we have to tell Unity that this is going to be a shader that wants lighting information. So to do that, we're going to see a new tag here, and it's light mode and it's forward base. So this is our forward base pass. And there's other tags for light mode as well. We're going to go into those in the next tutorial. This one we're going to be keeping this as simple as possible by just doing a vertex lit shader. When we get into pixel lit shaders, then we're going to have to add a second pass. Okay, so the big thing with lighting, you're going to hear this a ton, is N.L. And I'm just going to pull up an image here. So this little image kind of shows what N.L is. And what we really want when we're dealing with lights is we want this angle. So we need to know the angle between these two vectors here. And this vector is the surface normal, and we already know how to get the normal, and that's actually quite simple. The normal is actually handled automatically for us, so the normal will be passed in to our vertex program in the vertex input struct, and Unity fills that in for us. And then we have something new here. This is going to be our light, and we need the direction to the light. And what this allows us to do is get this cosine, and we can use that to see how much the light is affecting this exact point on our shader. Now, in the case of a vertex lit shader, this is going to be for each vertex. When we get into pixel lit, it'll be for every fragment that we actually have on here. And this is why vertex lit shaders are so much more efficient and performant than going down to an actual pixel lit shader. So the final equation we're going to end up for our lighting, our diffuse lighting, is the incoming light times the diffuse color, and that's just going to be the color here, times the n dot L. So n dot L, how we're going to get this cosine here. Now, the easiest way to get it is to take the dot product of this normal and this light. And the reason that gets us the cosine here is because if you remember from math back in the day, the dot product is the magnitude of this first vector times the magnitude of the second vector times the cosine of this angle between them. In our particular case, we're going to have normalized vectors. So the normal is going to be normalized. The direction to the light is going to be normalized. So the magnitude of two normalized vectors multiplied by each other is just 1. So we can essentially ignore that part of it, and when we do n dot L, we end up getting the cosine of this angle. Okay, so now that we know what we need, how do we actually do it? And now our final goal is going to be to get that incoming light times the diffuse color times n dot L. So first thing we need to do is we need to get the normal, and we need to get that in world space. So this is fairly ugly code right here. So what we're doing here is first we're taking this this normal, which is the normal is actually just a float 3, and we need to multiply it by our world to object matrix. And this is something that's one of the Unity magic variables. It's automatically populated for you. And when we're dealing with the normal here, and we want to multiply it by that, we need to make sure it's a float 4. So we just throw in an extra 1 here, and when that ends up being multiplied by the matrix, it's something that's not going to affect what we're doing here. And then what we do there is we grab the just XYZ, so we grab just the vector or a float 3 out of this, and then we normalize it. Now, this line of code is ugly. It's really ugly, to say the least. So this is something that we're going to be doing all the time when we're dealing with lighting. We're going to need to take that normal, and we're going to need to get it into world space. So this is a perfect opportunity to use our include file to make this cleaner. So what we're going to do is we're going to have a look at the include file, and you'll see it just has a simple define in it. Now, CG lets you use defines. I could have also made this an actual function. In this particular case, I just used a define. And instead of having this ugly piece of code in your shaders all the time, you'll be able to just simplify it down to normal to world. So let's go ahead and replace this ugliness. Okay, so that's a lot easier to look at. I can tell what it's doing a lot easier than previously. So much better, much easier to work with. And this is something for you use your includes for all the time. Anytime you have ugly code that's going to be duplicated all over the place, just stick it in an include file, make it nice and clean, give it a good name, and then you'll be able to actually read your shaders later on. So the next thing we need is going to be another magic variable from that Unity will populate for us. So it's something called Worldspace Light position. And the Worldspace Light position actually isn't always a position. It's going to be either a position or a direction. In the case of a directional light, and that's what we're working with today, it's going to be a direction, because directional lights, the position doesn't matter. You can put them anywhere you want, and it's always going to act the same. So all we care about is the direction. Now, if the Worldspace Light position variable was actually populated with a point light, then what we would have is a position in world space. So if it's the same variable and it could be either a directional light or a point light, how do we know what it's giving us? And the way Unity does this is they made Worldspace Light position a float 4. So it has that extra W parameter or W value in there. And in the case of a directional light, W is going to be 0. In the case of a point or a spotlight, it'll be 1. So that's how we can use the same variable and know if we're dealing with a directional light or a point light. So we'll know if we have a direction or a world space coordinate. So the Worldspace Light direction, so we're dealing with directional lights, is going to be what we're working with today. Is actually going to be that position or the direction. I'm not 100% sure if it's normalized. I can't find any information in the documentation to say if it's normalized or not, and Grandmaster Shader Writer Aris has not answered yet. I shot him a tweet to see what it is. So I always normalize it just to make sure. So once we actually find out for sure, we'll either be able to leave it normalized or take away the normalized. But for now, we're just going to assume that Unity's not normalizing it. So this is the Worldspace Light position. You can see there's a 0 after it, and that's just indicating that it's the first light. And we're only dealing with one directional light for this tutorial, so that's all we need is that particular information. So now we have N and we have L. So if you remember from our equation, we needed, in order to be able to calculate the lighting, we need the incoming light times the material diffuse color times N dot L. So we have almost all that. The missing piece is the incoming light. And this is, again, another Unity magic uniform. So in order to be able to get the light color passed in, all we have to do is tell Unity we want it. So again, we're dealing with light color 0 because we're only dealing with the first light, and it's a single directional light. Okay, so now we have the light color, and actually now we have all of the bits of the equation that we need. So we can actually go ahead and do the diffuse calculation now. Okay, so that's our diffuse calculation. So let's break it down. So we have incoming light, and we only need the XYZ portion of this. And then we have our diffuse color, and then we have right here our N dot L. Now you can see that I'm doing a max of N dot L here. And basically what this is doing is clamping it between 0 and 1. And the reason we want to do that is because if the light is actually on the opposite side, then N dot L is going to be a negative number. And we don't want to stick negatives in here because then we'll end up reducing our light color, or the color of our final color, and it won't look right. So by just sticking a max in there, we'll ensure that we're only getting lights that are on the correct side of our particular surface. Okay, so last little piece here is, instead of passing color in here, we can just take that diffuse lighting that we calculated and pass that in. So let's jump over into Unity and see what we got. Okay, so we have an error. Excellent. And what do we have here? We can't convert float 3 to float 4. So let's go ahead and fix that. Okay, so the issue right here was that diffuse is a float 3 and color is actually a float 4. So what we want to do to fix that up is just make it a half 4 and stick a 1 in for the alpha value. So now we can jump back over to Unity. And there we go. We have lighting. So I'm going to go ahead and grab this directional light. And again, we're only dealing with the direction, so moving it is not going to have any effect. But changing the direction will have an effect. And you can see that we are, in fact, getting the lighting contribution in there. And if you want to visualize this, one handy way to do it is over here you can see what we're doing is we're just multiplying the value we get from the texture by that color that we calculated. If you just remove this and just stick that diffuse in there, so you can actually see what your lighting contribution is here. This is a real handy way to see what's kind of debug your shaders and make sure everything's working the way you would expect it to. Okay, putting the texture back in there. And you know, the sphere over here is the best way to see lighting. Planes aren't so interesting. Capsules are also fun for playing around with lighting because you get lots of different surface directions on there, and it has a ton of verts. And there you go. That is about the most efficient lighting you can possibly have. This is really good for mobile. because you're dealing with only a single directional light. All of your calculations are occurring in your vertex shader. You can see we're not doing all we're doing is grabbing a pixel out of the image and multiplying in our fragment shader. So this is a super efficient way to have basic lighting, great for older mobile devices or if you have a lot of stuff on screen. So in the next tutorial, what we're going to do is we're going to modify this shader so that it works with point lights, and then we're going to add in specular highlights. That's it for now. Thanks for watching.